Okay, hi guys. So today we are going to talk about the database recovery. So, as we all know, we are living in the era where data has been the reason why some company can stand and competing with the multi-billionaires companies. So, because of the value of the data that they have. So, having a database is a must, right? So, by having a database means there are possibility of database failure or data loss due to some inconvenience that would happen. So it happened unexpectedly, right? And losing a database means you're pretty well doomed and you lost everything, every data that you have ever had. So that's why programmers come up with a database recovery solution which would help every person to recover and rebuild the database without losing any data. So let's get into it.
So, database failure or loss can come from many different forms and ways, such as catastrophic failure, earthquake, tsunami, virus infection, incorrect data insertion, aborted transaction, or maybe a nuclear war. Hence why we have database recovery solutions to recover missing and corrupted data in the database system. Without any fuss, let's get into it, okay? So, database recovery, disk mirroring. To better understand what disk mirroring is, yes, the first word that comes to your mind is duplication of data. Basically, it will update all the data to separate disks simultaneously, which means two or more drives are working at the same time, storing every transaction that is being done by the system. It is also called as RAID, which stands for Redundant Array of Independent Drives, or Redundant Array of Inexpensive Drives. So, RAID has many levels. Usually, a company will implement RAID level 5 and above to make sure the safety of data in their system. So they are rate 0, rate 1, rate 5, rate 6, and rate 10. And rate is a software that control the functionality of the drives and usually comes with Windows Server 2012 and as well as Mac OS X. Rate 0. Rate 0 is a basic rate where we already applied in on our desktop, where we have solid state drive and hard disk drive. If one of them failed, the other one still can be accessed. However, the data in the failed disk will be a total loss. Rate 1. So, rate 1. This is where the word redundancy plays its roles. So, when the data is stored, it will be stored twice by writing them into both drives, also called as mirrored drive. So write and read speed are comparable to the single drive, and it is safe and easy to recover the data. There's no need to rebuild the data in case of failure. We just need to copy from the mirrored disk to the replacement drive, which is the new drive. More disk, it commonly used by company because it can store a huge amount of data and it is noticeably fast. The speed of both rate is about the same, which is rate 6 and also rate 5. So in order for us to understand how rate 6 works, we need to know how rate 5 works first. So in RAID 5, data is not duplicated, so it is spread, or in database jargon we call it as striped, to multiple disks along with the parity. Parity is the data that is spread evenly to every disk so that every database will contain the same amount of information, which is important to recover and also to rebuild the database in case of failure. Let's say one of the disks is not working. RAID 5 is designed to handle a single disk failure, and it will use the parity from each remaining disk to rebuild the replaced disk. All we need to do is replace the disk, and RAID 5 will do its job rebuilding the information that is lost. But if two disks were to fail at the same time, RAID 5 cannot handle two disk failure at the same time. Because why RAID 5 required more than three disks? Is because if there is 3 terabyte of storage, 2 terabyte of storage will be used to store the actual data, and the remaining is to store the parity of the database that is used to rebuild the broken database. In RAID 6, however, it is pretty much the same as RAID 5. Parity is written twice to each disk, so each disk will have two parity and can handle two disk failures simultaneously. Hence why it will need more than 4 disks to make RAID 6 a successful database recovery and rebuild. Same goes to RAID 6. It, if it has 4 disks, 2 disks will be used to store the actual data and the other 2 will be used to store the parity of the database. One thing that we need to know about RAID 6 is it is much slower when writing data into the disk, as it will have to write double parity compared to RAID 5, which only have one parity for each disk. Finally, RAID 10. RAID 10 is a combination of RAID 1 and RAID 0 architecture. In order for us to understand RAID 10, we need to know that RAID 10 is the combination of RAID 0 and also RAID 1, the method of striping and also mirroring. So here how it goes. By looking at the animation, we can see how the data moves through RAID 0 architecture and then mirrored by RAID 1 architecture. The RAID 10 can benefit very much from RAID 0 speed on striping the data into each disk, and also the fault tolerance of RAID 1. But the downside of it, user can only use 50% of the disk to store actual data, and the another 50% is for the backup. That's all from me on database recovery about this mirroring. Thank you.